Hello everyone. I hope I'm audible and visible. I can see the students are joining, and we have the panelists here too. Good morning everyone, and thank you for joining. We have an amazing set of panelists today to talk about uh, the environment here. First of all, a short introduction to our team. We are the R-Connect team. Work towards industry academia collaborations. We always try to bridge that gap between academia and industry. And today, as the experts from the industry, that to public sector and private sector, we have an amazing panelist. And on top of it, this panel discussion would be moderated by one of our own professors, Professor Indumathi ma'am. Let's just get started with it. Yes. I hope my screen is visible to all of you. As we all know, today's theme is engineering the environment. The topics that we will be covering would be general views and problem statement areas that need to be covered in the area of environment. As engineers and most above all as researchers, there are various problem statements that we can solve during our tenure over here. Even if you are a computer science student or even if you are a mechanical engineering student, there's always problems that we can solve using our mind and our time. Today, these panelists would be talking about the areas that we can look upon to and which mostly revolves around the quality of water, waste management, forest areas and such. But the highlight is they would be telling you on how to upskill yourself for the future and the opportunities that are present in public and private sector. Today we have a lot of panelists. We have 5 speakers over here and 1 moderator too. And they are from different sectors. There is private sector, public sector. They have different jobs, different areas. They are in different corners. But one thing ties all of them. One thing is common for all of them. And that is the fact that they are environmentalists, they are nature lovers, and they all have one goal, that is sustainability. These are a various bunch of panelists tied by the same goal, and they are here together for us, and they are here to teach us. I'm going to introduce each of our speakers now. First, we have Mr. Arava Rajkamal. He will be our speaker 1. Mr. Rajkamal is an IAS officer, district collector, and district magistrate at Aditipur, India, with a master's in public administration from Harvard University. His expertise are in district administration, infrastructure, and economic development, supervision of public projects, and much more. And one fact, he is an IITM alumnus too. We look forward to hear from you, sir. And next, we have Mr. Anand Krishnamurthy here. Mr. Krishnamurthy is the co-founder and partner at NWIP, a firm offering sustainability goals for industries. He is an experienced professional in infrastructure and environmental development who has worked on various private and government projects. His expertise involved in corporate sustainability, responsible investment, research, analytics, and much more. And he is an alumnus from IITM, IIT Bombay. And now we have Mr. Rajesh
IIT Guwahati.
Guwahati. Oh my God, my bad. Okay. I'm sorry. I apologize for that. Yes. And then we have Mr. Rajesh S. Kumar. Mr. Rajesh is an IFS officer, Chief Conservator of Forest with Government of Arunachal Pradesh. His expertise in environment and forest management, climate change adaptation, wildlife conservation, urban green space governance, and much more. He's also a grad from Harvard, and he will be here to talk specifically about the forest area. And next speaker we have lined up is Dr. Vijaysai. Dr. Vijaysai is the head of Water Technology Center Research and Development, Digital and Knowledge Hub at L&D, Water Effluent Treatment. His expertise involved as an experienced professional in water and processing technologies and wastewater treatment. So we also look forward from hearing you, sir. And now next we have Dr. Anand Ghumare. So Dr. Ghumare is an experienced research and development manager at the oil and gas chemicals and service provider company in Saudi Arabia. His experience involved synthesis, formulation, application development, and commercialization of oil field products and technological solutions to the field operations and much more. So he is quite an enthusiastic teacher too. He's always welcome to guide students. So we also had an amazing conversation with this particular panelist. And then last but not the least, our moderator for today, Dr. Indumathi M. Nambi, our professor. So, ma'am is our professor and researcher with the Department of Civil Engineering from our own IIT Madras. She is the director and founder of Samyukta Yoga Waste Chakra and the Carbon Zero Challenge Steering Committee head. Her expertise involved in environmental engineering, technology development in water, wastewater, waste treatment, and much more. So she will be guiding the entire, moderating the entire panel discussion and would be facilitating the entire conversation for today. And she was quite happy when we told that we would be focusing on the environmental area. So we are very glad to have her on board too. So the order of the speakers would be, each speaker would be speaking about 10 minutes or more, around 15 minutes. Our first speaker would be Mr. Arava Rajkamal, then Mr. Anand Krishnamurthy. Speaker 3 would be Mr. Rajesh IFS, then speaker 4, Dr. Vijaysai, then speaker 5, Dr. Anant K. Ghumare. And ma'am would be moderating the entire conversation, talking about the problem statement areas in the next session. So the agenda would be, we'll start off the discussion and there will be review by ma'am. Then we'll be taking up questions from the audience at 12:25 p.m. and then we'll be concluding at 12:40 p.m. So I hope all of you have a great session and we wish you the very best for this panel discussion from the Research Connect team. So thank you. Also, we'll be starting the meeting now. So one of our coordinators, Suresh, would be sharing the PPT for for our first speaker. So I'll be stopping the share now. So Suresh, you can go ahead and share. Yes.
Very good morning to firstly ma'am Indumathi ji and other respected panelists and students of IIT Madras and the Research Connect team. Especially I thank Deepthi and Anthony for managing me somehow. I mean, in the sense like, you know, I've been sending them mails at odd hours and they've been very patient in replying and clarifying my questions. So a little brief introduction about me. Next slide, please. Yeah, so my right now I'm a district collector in one of the districts of Jharkhand, which is bordering Odisha and West Bengal. So my my area of work is not entirely about environment. There are many verticals I work on, starting from law and order to rural development. So environment is the underlying theme. As Deepthi has mentioned, that we're all here for a purpose and we're all sensitive about the environment cause. So that is the underlying theme. And the previous districts that I worked are also very sensitive when it comes to environmental issues. I worked in coal mining districts, Bokaro and Devghar. A lot of coal mining activity takes place. And the previous district that I worked was in, it's one of the highest iron ore mining districts of the country. It's bordering Odisha and it also has Saranda forest. I'm sure that Rajesh sir will be joining after me, and is much more senior to me, and he must be, you know, having a lot of expertise and experience working with forest related issues. So I won't be focusing much on that part. But right now I'm working in an adjacent district to my previous district, which is adjacent to Jamshedpur. So basically, it's the land of the Tatas. So all the Tata Motors and Tata Long Steel products. So it's a big industrial cluster that is located in my district. So my experience is very, I can say that it's very district oriented. So my perspective will be very district oriented. So please bear with me. And I'm not going to give you a big picture that you may be expecting, but from a district, I can give you a perspective about what are the opportunities and what are the things happening at the district level. Next slide, please. So as I mentioned, India consists of nearly 720 districts, and most of the implementation of the work happens on the ground in the district level. So when you look at one of the important underlying themes of the district administration, it's also to protect the environment and provide clean water and ensure good air quality to the citizens. So the legal backup, I'm just going to give one of the advantage of going as the first speaker is I can go very broad. So I have included a slide where what is the legal framework that we have under which we'll operate. So the Constitution of India definitely mentions about the right to life, the purview of which has been expanded by the Honorable Supreme Court in 1991. In this judgment of Subhash Kumar versus State of Bihar, Supreme Court has said that a citizen's right to life expands to having access to clean water. So that is a landmark judgment, I believe. And also we have references of environment and public health in our directive principles of state policy, which is a guiding influence for the public policy in the country. And also as citizens, we expect the Indian citizens to not just protect, but to promote good environmental standards as a part of the fundamental duties. And we also have it even in the British era. We always had this section under IPC where anybody deliberately faults any water reservoir or any public water body, he can be penalized. So the concern for environment was always there, but the focus has increased in the last, I can say, in the last 30, 40 years. And the main act that we use, it's like the bread and butter of environmental management in the state and the districts, is the Water Act. The Central Pollution Control Board and the State Pollution Control Boards are formed on the basis of this act that came up in the 1974. And Forest Conservation Act is a very important act, and I am sure that Rajesh sir is going to focus on that part, so I'm not going to go dwell much on that. And there's also Air Act, in which the provisions are very similar to the Water Act. And the most important act is the Environmental Protection Act. The Water Act ensured the formation of Central Pollution Control Board and State Pollution Control Boards, and it created an administrative structure to manage the more of a command and control kind of a system for environmental management. But Environmental Protection Act empowered the Ministry of Environment, Forest and Climate Change to declare certain areas as environmentally sensitive and declare standards at a national level. So that it gave a lot of teeth to the central government, and it's a very landmark act, I believe. The next slide, please. And these judgments are very, I could say, landmark judgments. MC Mehta, I think many of you must be aware, where in Kanpur, the tanneries were releasing the effluent into River Ganga. And the Supreme Court has taken it very seriously and made both the tanneries and also the Kanpur Municipal Corporation responsible for the nuisance of water pollution in that area. So this is a landmark judgment where the Supreme Court has made the key actors, including the public sector, as one of the polluters, and they made them responsible for that action, and also directed them to invest public funds in the construction of effluent management system. I believe it's a very similar case has happened in Vellore Citizens Forum also in Tamil Nadu. I think River Palar, I think a very similar case happened there. Not very sure about that aspect, but we deal with these cases in many of the judgments that we come across every day. And the real game changer is the National Green Tribunal Act. Whatever the environmental concerns that we have at the state or the district administration mostly are directed towards handling the court cases pending in the National Green Tribunal. So all the acts that I was mentioning before, NGT was formed to ensure expedited adjudication of the cases for aggrieved people under these acts. So NGT has 5 benches, and I'm very sure that people call it's almost like the mini Supreme Court. Very rarely you'll find a situation where the NGT order, you get any relief against the NGT's order in the Supreme Court. And it has all the teeth. And for example, I can quote some of my colleagues who also faced a situation where we were made parties in a sand mining contempt case, in which the NGT has, I won't say threatened, but they gave a direction that they're going to impose a penalty of 10 crores on individual officers. So that's the kind of power that NGT has. It can impose a fine up to 10 crores and even imprison any violator for 3 years rigorous jail imprisonment. So in a sense, like what I meant to say is that any order of NGT has the effect of an act. So any order in any minor case, any violation of that particular order of an NGT, a bench of an NGT, will subject you to this kind of rigorous imprisonment and a fine up to 10 crores. So it has the power and it expedites the adjudication of these cases. So it's no longer the long queue that we have in the honorable high courts or the other courts, but NGT especially deals with these cases. And you are I'm very sure that you're all aware about the environmental impact assessment. Many of the young students, I think this is the I think there may be courses also being offered about environmental impact assessment. I can share a couple of points regarding that as well. Next slide, please. Yeah, like I told you, the CPCB is the advisory body for the government of India, but the real implementation is done by the command and control system is exercised by the state pollution control boards. So SPCBs is more like an independent body. It is not part of the state government. It doesn't have any elected representatives. It has a structure of a board in which it is autonomous body. It has its own funding mechanism. It has its own operations. So they have a control on the establishment of industries right from the conception. Even before starting an industry, you have to take the consent to establish, and then on a periodic break, you need to take the consent to operate. So there are different categories also. Many different states have different criteria for that. The green is generally the least polluting industries, mostly waste management kind of industry. You can think of a green industry where you need to take the CTO for every 10 years. When it comes to red categories, the steel or the other more polluting industries where you need to take the consent to operate every 2 years or 3 years. So also they're part of the mechanism where the EIA hearings takes place. The big companies, or be it a big public infrastructure project, whenever it happens, the environmental impact assessment takes place, and this state pollution control board takes the objections from the people who are living in the neighborhood and sends them with a report to the Ministry of Environment, Forest and Climate Change. And this is a very new development is the district environment committee. It's a very new development. If you see in the districts in the last, before 2 years, this committee never existed. It is also a direct effect of National Green Tribunal. NGT has issued an order that every district should have a district environment management plan, and to prepare the plan and to monitor it at regular intervals, a district environment committee needs to be formed. And most of the districts, I think almost all districts of the country have formed the district environmental management committee. And district environment management plan consists of various aspects, not just the water and air, but ranging from hazardous waste to biomedical waste and e-waste, even issues of noise pollution, mining and industrial effluents. The comprehensive plan needs to be prepared, and most of the districts have done it, but it's still in the draft stage. They're supposed to publish it in their websites, and a copy of it has to be submitted in the NGT. So that process is still going on. It's a big exercise and work is underway in many of the districts. But unfortunately, we don't have the specialization in the districts. Hardly we find any environmental engineers. We need to borrow engineers from big private companies. We had to take the support of Tata's and other private companies. We ask them to depute their environmental engineers. So always that aspect is there. I mean, even the districts who can afford to prepare a district environmental management plan, that template is used for the other districts. So it's not that you're going to do anything, very specific to your district. It's more like a general exercise. Next slide, please. Yeah, the real, the day-to-day thing that we use is the criminal procedure code. The CRPC 133 allows the district magistrate or the subdivisional magistrate to clear any public nuisance. It can range from removing a sludge or a disturbance in a river uh, to completely stop a mining operation if it's going to cause noise pollution or it's going to impact the health of the people, health of any people, people living in the vicinity. When I was SDO, we had this situation where the blasting was taking place in the Eastern Coalfields Limited, where the nearby houses were damaged. So I, as a young SDO, I had no idea. I just read the CRPC. I thought, I don't know, let me try this out. So when I issued the injunction, the GM had to appear in my court. It's a very small subdivisional office. The GM had to come down from Kolkata. He tried to contest my order in the High Court, but still he couldn't get any relief. So but the power of the executive magistrate is very very high when it comes to this kind of temporary relief. But in a long term, I'm sure that we need more legal remedies. And also we did a very similar thing about ash dumping in riverbeds. Many steel companies, they started dumping the ash in the riverbed. So we issued an injunction to them. The order reads in such a way that you either remove the nuisance in 24 hours or you appear in the court in 24 hours explaining why it should not be imposed on you. So a fine or administrative action. So it's a very powerful mechanism that is used across the country. And we have a district monitoring committee. It's called Disha committee now. The government has changed the name, in which the honorable MP, if there are multiple MPs, the MP with the largest area or the senior-most MP will be the head of the district vigilance and monitoring committee, which usually deals with the issues of issues related to public grievances. Mostly in industrial areas and mining areas, we keep getting these complaints about pollution. So most of these inquiries are done by the Disha committees. And we also get complaints from PM portal and also the CMO and all. So basically, generally, there is no constant monitoring mechanism as such for the operations of these CTOs, whether they have been following the environmental clearance norms. We only take cognizance when we get a complaint. That's unfortunately is the scenario right now. And we also have a mining task force to check on the illegal mining activities in the riverbeds. And a big change, a very new development is the District Mineral Foundation Trust. DMFT is a game changer in most of the eastern districts and where most of the mining districts of the country, where 30% of the royalty that is given to the government is deposited at the district level. So the district account has the earlier, for example, the district that I worked previously had no money to spend at the district level except some funds under LW in Excel area development. But this fund, I mean, the quantum of the fund, I'm just going to give you a glimpse of it. It's almost like we have a fund of around 1,000 crores at the disposal of the district. And there's a mandate from NGT saying that at least 10% has to be spent on environment. So there's a huge scope. I mean, this avenue was not available 5 years back, but when the DMFT Act came in, now the district mineral foundations have been formed in most of the states. I mean, wherever there's a mining activity, it's there in almost every district. Even at least the sand mining takes place in most of the districts in the country. So this is a fund that is available at the district level to handle the environmental issues at the district level. It's a big opportunity. And I don't want to dwell much on the MPSM. Next slide, please. So the challenges. Cess Act, Water Cess Act. So there used to be a cess given to the State Pollution Control Board, based on which they used to run their board and pay the salary of the employees and all. But now, since the GST has been brought in, I think that cess has been repealed. So now, mostly they're dependent on the CTO, the charges that they get while the CTO is issued. So financially, they're not that independent. And there's no clear direction, no mandate as such, and also the ease of doing business. I think the country also wants to end the license permit raj, so they don't want to trouble the industry much unless until they receive a complaint. So the enforcement mechanism of SPCB has weakened a lot in the previous 2 decades, but now it's like, yeah, I'm just winding it up. So, like I told you, unless the courts are involved, district administration generally don't take it as a serious issue. And the impact assessment, that EIA hearing that we often hear, often we come across, almost all the time, the environmental issues take the backseat. Most of the time, the villagers, uh, they're not able to understand the cryptic EIA reports, be it the short report or the long report. Most of the people talk about the local jobs or the local infrastructure creation. So that takes a backseat. That's unfortunate. Next slide. I'm just going to give you a small case study about Roro. I think you can browse through about it. It's a asbestos mine that got closed nearly 30 years back. The next slide, please. Next slide. Yeah. So this is taken up by the NGT. And I'm just going to give this case study to make you understand the complexity of an environmental issue. There are many social, economic, environmental, and also there is a security scenario also involved. Right now, there is a deposit of nearly 1 million tons of asbestos, and we're trying to remediate the entire land. We were taking the support of National Environmental Engineering Research Institute, NERI, and they have given an estimate which is still beyond the means of a small district. Like I told you, the DMFT fund is available, but it's not the case with all the districts. So I think low cost technologies and speedy remediation can be something that they can work on. And also the impact of pollution on the health, public health. So that translational research has to be done, and that needs to be, quantified and needs to be emphasized in the policy. That is where I think the research can really chip in. Next slide, please. Yeah, so we started with the NERI was supporting us, and they gave us a lot of research inputs about asbestosis and how can we contain it and manage the disease. Next slide. Yeah, the opportunities, I'm just going to take 1 minute. So like I told you, I was giving a brief overview. There are many non-toxic contaminant removal. I mean, there's a need for non-toxic contaminant removal. For example, in the previous issue I worked, the level of iron in water, groundwater, is 5 times the standard that is given by the WHO. So we don't really know whether it's just an aesthetic thing. It's just about taste of the water, or will there be any health impact? So that emphasis on health, that is missing. The link between pollution and public health, that needs to be established, and that will help us in calculating the compensation as well. So right now we don't have a mechanism to how much compensation should we give the patients with asbestosis or people who are victims of water pollution. So that part where the research can come in, and there's a lot of demand for low cost remediation strategies, and also almost every district in the country has requirement for technical personnel who can come and do testing of water, especially near the polluting industry or even the waste management plant. In my district, there's a bio waste management plant, and I keep getting the complaints almost quarterly about the water quality in that area. So we need to have that mechanism where we continuously keep checking the quality of the water in that area. And the biggest opportunities in infrastructure, like I told you, the 15th Finance Commission, the government of India is going to give money to the panchayats and blocks and districts, and 60% of the money will be spent on water and sanitation. So it's a tied fund. They cannot divert the fund. There's a huge opportunity for infrastructure development in clean water and sanitation. And I believe this is the time where the people should move from metros to small towns, Y and Z towns, where the real infrastructure growth is happening. For example, in IITM, where I was working, it's a small municipal corporation with 4 lakh population, when it has projects around 1,000 crores, where a big L&T and Shapurji Palanji, they're working on the sewerage plant, and they're also working on Jindal is working on a drinking water project, underground water pipeline project. So I'm telling you, the scope is immense. And if we can add the Jal Jeevan mission to it, it's tremendous. Jal Jeevan mission aims to give functional household tap connection to every household of the country by 2024. You're talking about every household, just like the electricity connection that we gave even to the people in the far-flung areas. If you give the water connection to those people, I believe it's a huge investment involved, and there's a great public good that we're providing. And next slide. And also we want to minimize the difficulty for the people. while the infrastructure project takes place, I mean, especially in small areas, because the population is very dense and the cities are not planned, the least amount of inconvenience, if we design technology, or I think it's more of a civil engineering kind of a thing, where we ensure speedy reconstruction activity, least disturbance, because the economy of the city is very much dependent on that dense populated areas. So if some technology or new innovative methodology can be developed where the restructuring becomes very smooth, I believe that will be, a very highly required, highly in demand, technology. Next slide. That's it. So I thought I'll just give a overview about things happening at the district and the opportunities that may be available in coming years. Thank you.
Thank you, sir. That was quite insightful information. So let's move forward to the next speaker, Mr. Anand Krishnamurthy. Yes.
Yeah, thank you. I'm just going to share my screen. Please let me know if you can see this. Just 1 second.
Sure.
Yeah. You can see the slide?
Yes, we can. Yeah.
Okay. Very good morning to all. Thank you, Professor Indumathi, my fellow panelists, and of course, Anthony and Deepthi, who have been interacting with me very patiently for the last many days. And thanks to all the participants for joining on Sunday morning. And Raj made some very, very interesting points on starting with the legal and administrative framework, and then illustrating some of the ground realities and challenges that are there in front of us. And of course, he highlighted the opportunities that these challenges also pose. What I will try and do in my next 10 minutes or so is um, really focus on maybe water sector a little bit as to how it has evolved and what has been the history and but more importantly, what's the future going to be like. I think it is important to understand the historical context of all the sectors that we operate in, be it water, waste, or electricity, and then look at some of the current happenings and where the future lies. That's how I take this presentation through. My focus is also going to be on the corporate sector and what has been changing for the corporate sector in terms of their relationship with the environment. I myself, I'm an accidental environmentalist. I never intended to be in this profession. It just so happened that I used to work in GE in the water industry many years ago, and water and wastewater treatment. And when I saw in front of my eyes the kind of magic that happened with some of the technology that we used in terms of in cleaning sewage, cleaning effluent, and Vijaysai was very much there with me in many of those projects. It was very inspiring and eye-opening, and I just continued to in this field. Now let's look at the water sector, and I like to illustrate this by as 9 drops of the water sector in India. If we look at the past, and this is many years ago, and say 40, 50 years ago, we started on the back foot. Even many years ago, we had a per capita availability of water that was much less than many other countries, and it's only being decreasing since. Well, many people say that per capita availability is not the right measure. I agree. But at a broad level, it is not that we have places that are blessed with water, but we also have places that haven't seen water abundance for many, many decades. It has also been mismanaged and undervalued. We have the lowest tariffs in the world in the water sector today. So drinking water is often taken for granted, and which leads to a lot of mismanagement. It has also been historically an underinvested sector, and the focus of our previous leaderships and many years ago was on building dams, on irrigation, on very, very large scale projects. and somehow the urban infrastructure and the rural infrastructure or more decentralized infrastructure needed for water and wastewater treatment didn't get that preference, which has led to what I call as a stressed present. I mean, we are all undergoing this. Our cities are choking, villages are unsafe. There is a lack of skill at an India level. If I see, I mean, we are sitting in a privileged group where a lot of people are aware of the sector and have the skills to deal with the issues. But given the population of India, given the scale of the problem that we are looking at, there is definitely a lack of skills in addressing these challenges today. But what I see as one of the positives of the present is that industries are waking up to reality. And it happens when they don't get permission for extra water when they are about to expand their capacities. So this has been happening in many states, and industries are now realizing that it is not possible to just ask for water from the government and just get it, and they are being pushed to consider more options on how they can utilize the existing water and make do with that, even though they might be expanding. I do have a very positive view of the future. The As Raj spoke about our drinking water mission. I mean, it's a massive, ambitious mission connecting all households with drinking water connections, and so the aspirations are certainly very high, and it should be so. Our river cleaning projects are also pretty large scale, and I'm sure they will go beyond the NMCG to many other rivers, and we will see a future where our rivers will be much cleaner and have much lower um, ingress of sewage or effluent. There are also climate risks, and India is amongst the most, I think, about the seventh or eighth most vulnerable country when it comes to climate change. And it definitely portends a future where adaptation needs to be very keenly looked at and understood from a water wastewater perspective. There is a push for water security, and it will, as I said, the per capita availability might be low, but it doesn't mean that as a country we don't have enough water. I think we can make do with the existing water if managed well, if reused well, recycled well, and if the pricing is correct, etc., etc. So that's how I see the water sector in India. And let's move on. Why should we look at the water sector so seriously now? And there are 600 million Indians facing high water stress. I mean, these numbers are well, meaningless if you're undergoing water stress every day. If you're living with water scarcity or seeing dirty water everywhere, you are one of those 600 million. And there are, I mean, you can see some of the statistics there, right from sourcing to distribution uh, to the some of the usage that is there across agriculture, and there are a host of issues to contend with. We have the highest groundwater withdrawal in the world, higher than that of China. We often hear of a desalination, but is that a viable option for probably only for a limited set of people? Only 30% population is connected to a water network, and there is a large proportion of non-revenue water that exists in cities in India. So I do think that this is one of the most exciting sectors for the environmental engineers to make a career in, because we have these problems right now, but I don't see that 20 years hence we will have the same problems. I think a lot of them will get resolved, and a lot of them will get addressed with technology, addressed with government policies, and because as a nation we are a problem solving nation, and I do wish to believe that this uh, uh, the generation now can address these challenges and make improve on these metrics. We have the SDG 6 goals that will lead us forward. We have to work on climate change mitigation, and uh, as Raj spoke about NGT, you might be aware that about about 2 weeks ago, NGT also got suo motu powers from the Supreme Court, and that's a very positive development. And NGT can really now put pressure on a lot of violators and take them to task if they are messing around with the environment. So regulatory regime is definitely going to be stricter, Unfortunately, the enforcement regime at the SPCB level has not been so strict as we would like. But I think with better citizen participation, better civic understanding, I think these, when people become more aware of their rights, I think these will also move in the right direction. Beyond water, I mean, let's look at what some of the world leaders are saying. Now, business leaders as well as global leaders, environment is there in the eyes of everybody, and it's there in the minds of everybody, in the words of everybody, right? From our Prime Minister to the President Obama to a lot of global leaders. Environment is now, and climate change is occupying a very large mind share. And this is again a positive development, because a lot of these changes will start at the top, and even the business roundtable, which has participation from about, I think, the 200 of the largest US corporations, they have expanded their purpose statements to not just look at financial investors, but a larger set of stakeholders. What this has done, and I'll now transition to the corporate stage of things. What these developments are doing is that there is a lot of corporate pressure now to act on the environment. Corporates are now seeing the environment as an important stakeholder, and not just something that you can, not just something where you need to comply. So the corporate outlook will now change from just compliance to beyond compliance as to what can they do for the environment. I think this again is a very positive development. Let's move on. And you could see from, I've taken one example here of how business models are changing. Reliance Industries, the petrochemical behemoth, which is there, which has got thousands of crores of investments in petrochemicals, is now dramatically changing its strategy to become greener. And in the last 1 week or so, you've seen about 3 or 4 acquisitions that they have done in electrolyzers and photovoltaic cells, in setting up an ecosystem that will be dependent on hydrogen, and it will be on it will be fully integrated on solar energy generation. So they have committed to net zero emissions by 2035 and 60,000 crores of investment in the renewable energy ecosystem. Now, Reliance is obviously looking at something as trends that the world will change in the next 2 decades in a quite fashion. And may I request everyone to be on mute, please? Thank you. So there are these, now Reliance is just one of the examples. Adani is there. A lot of other companies are there that I was speaking to somebody from JSW. They're also going to be investing in renewable energy in a very, very large way. So fossil fuels dependence will come down. Electric mobility, you've seen how the companies are investing, are and looking forward to it. So the world will change quite dramatically from the corporate perspective, and corporates will have a large role to play in adopting, not just adopting environmental friendly technologies, but also investing in these, doing more research. If Reliance is investing so much, they will need very, very good researchers. They will need technicians, engineers to be able to deliver on these promises. I do think corporate sustainability is coming of age. If you look at the relationship between the corporates and environments in 3 phases, the Rio conference was quite seminal, and before that, before 1992, a lot of the corporate mindset was on pollution control, on human rights. In India, it was a closed economy. It was the license Raj regime. In the 20 years between Rio conference to say about 2012, a lot of discussions happened around climate change, governance. In India, the capital markets became more developed, and companies became more answerable to the investors and shareholders, and corporate governance became came more in prominence. And in the last decade or so, before and after the Paris Agreement has been signed, there are a host of other developments that have happened for corporate India. And like business responsibility reporting, mandatory corporate social responsibility spends. And right now, they in May 2021, there's also regulation that's come from SEBI that's called the BRSR, which is Business Responsibility and Sustainability Reporting. It's a very interesting directive which says that companies have to disclose on their environmental performance, social performance, etc. And these disclosures are not simple. I mean, these are quite comprehensive in nature. To take an example, what's the total usage of water? What kind of source you're drawing the water from? How much are you reusing? What are you doing for recycling? Do you have zero liquid discharge? These are questions that companies will have to start answering now. And a lot of the good changes start with simple disclosure. When companies are forced to disclose, they will realize that probably they don't even have the metrics to disclose. They will go back to analyze what's their water consumption, what is the wastewater quality, etc., etc. And then they will look at uh, okay, then now I've disclosed this, but my competitor is better than me in these aspects. His consumption of water per unit is lower than mine, so I should be doing something about it. So then peer competition will start. So I'm very happy that this disclosure has come in, and it is applicable to the top 1,000 corporates in India, and that's a pretty large number. And if you start looking at these BRSR reports from next year, I'm sure environmental engineers will get a lot of insights on what are corporates doing around the environment. This, of course, includes energy, waste, and air emissions as well. To summarize, I think it's a great time to be an environmental engineer, and we should all be happy that we are in a field that has so many challenges for us, and it's for us to address them. India's environmental challenges are unique, and we are very fortunate to have two people in the panel today, Raj and Rajesh, who are with the government and who are looking at the ground realities. I'm sure they'll be able to throw more light on this as to why they are unique and why we need cost-effective solutions to be able to address the large-scale problem that we have, given the limited resources. Enviro-legal issues will become very, very complex and will need expert inputs. The NGT itself has their hands full because they are looking at issues ranging from, say, tannery effluent to asbestos to it maybe something else which needs a very sophisticated thinking around the environment, and as researchers like you who have deep understanding of the subject, because corporates will have their own side of things, government will have their own side, and these will become more contentious and will need expertise to resolve. Monitoring and disclosure will become more sophisticated with the growth of sensors, artificial intelligence, etc. I think it's a very positive development that we will be able to understand and what is really happening around the environment. What kind of constituents do we have to address? How much are these? What ppm is this? I mean, it's no longer good to say that it's in the range of 200 ppm. Is it 220 or 230? We'll be able to get that uh, exact number, and we'll be able to understand our problems in a more scientific and methodical way. Finally, I'd like to end by saying that we have we have lived in scarcity, and as a society, we have been innovating very well given the resources that we have. With as our ancient people have been, we understand sustainability in a very intuitive manner, and we know what it means to be sustainable. It is just that we have to put these things into practice at a national level, and have to not get overawed by the challenges that we have in front of us, but to take them head on, and to really propel India to become a exemplar in solving environmental issues. Thank you.
Thank you, sir. So there was a lot of information that we never knew. So thank you for that. So now we're gonna move forward with the next speaker, Mr. Rajesh. Sir, could you please share your screen? Sir, you're on mute.
Is it visible?
Yes, it is. Thank you,
Yeah,
sir.
thank you so much.
Please proceed.
Good morning to all of you and our leader, Professor Indumathi, and dear colleagues. It's really heartening to witness that today we are spending a Sunday to discuss about environment, and that too particularly on water issues. And more importantly, yes, we should be happy to feel ourselves that we are also looking eagerly forward for the Glasgow meeting on the COP26, all about climate change, which is going to happen soon. So, Mr. Raj and Mr. Anand, they spoke a lot about the legal institutions and governance arrangements, and also about the current state of affairs in the context of water conservation. So enough of context setting has already been done. So I will be focusing mostly on the areas where we can now approach the challenges with the technology. As Mr. Anand has pointed already, the situation has become more complex in terms of monitoring the processes, and also in terms of the low resource settings in which we are in. So the clear answer to that will be a strong involvement of technology, that too at a cost-effective and scalable level. This is the way forward for us. So within the context, I will take your attention to the whole context of, sorry, just a moment. Okay. So all context of natural resource conservation with a specific emphasis on biodiversity, and further micro emphasizing on forest management. And we'll discuss with some case examples as to how we can harness the potential of technology to address some of the complex challenges which now we are facing in these sectors. This is just a piece of introduction from the United Nations Drugs and Crimes Executive Director. So as the previous US President Obama and the current UN Secretary General have put already, climate change is a problem and it is an emergency. And unfortunately, we don't know at this moment, but unfortunately, clearly we can say we have been living in the times of emergency. There's a water emergency, there's a climate change emergency, there's a resource emergency. Everything is like the sort of emergency in which we are now fighting with. Yeah, of course, our fight is also limited because of our constraints in resources and also the abilities to respond. That has been very clearly explained to all of us by Raj in the morning, how it is difficult to handle these situations at district level, particularly when we don't have enough qualified hands. Though we have resources, but we don't have qualified hands even at the district or state level to address these issues with science and evidence. So I will now draw your attention to a bit of biodiversity, because we also spoke about water in detail, but biodiversity, we can consider it as a sort of macro level indicator. Because when biodiversity exists in its all integrity and strength, when all other supporting ecosystem services are very well functioning, which will include air, water, and land. So biodiversity definitely is a case for a macro level indicator for a common man. If a biodiversity intact, all our systems are going to be intact. Though it sounds like very apparent, like the way environmental concerns were sounding very trivial in 80s and 70s and have become very strong nowadays. Biodiversity is also a parameter which I feel that we should connect now and push it forward and take all measures across the sectors to protect it. Now, I will just take a little bit of your time to draw a micro sector in biodiversity management, of course, in the lens of illegal wildlife crimes. Why I'm again picking up wildlife crime? Because this is something which is connecting to us every day. So, and also at the same time, reflecting upon the level of biodiversity conservation our society is supporting too. Now look at wildlife crimes in the world. What are wildlife crimes? We'll just quickly understand in a moment, but we'll try to first sense it from a macro perspective as to how big these organized crimes are. There are 4 major organized crimes in the world. starting with the drugs, illegal drugs, which we know it's rampant across the world, and with a illegal trade volume of 320 billions. Next is about arms, which we are very popular, and we have a $60 billion dollar worth market for that. Then comes human trafficking, 32 billions. And what is important is wildlife crimes are again 20 billion. This is not just very far from human trafficking. But what is unfortunate here is that all the other three categories, illegal drug, arms, human trafficking, all get the attraction of media and the social attention when they are caught or detected. But wildlife crimes, though they're also very much near to human trafficking in terms of the trade volume, they hardly get much attention. But this is the area perhaps we are missing. Because of this poor attention, we are losing our sensing controls over many other key vitals which are supporting ecosystem services. Now look at this picture. Probably you are sure that these are some of the animals in the ecosystem, and unfortunately, all these animals are in wildlife trade as well. What is important here is you can spot these animals are there from land to mountains to sea and to the the bottom of the sea. So this trade is not leaving any animal left. It's simply really profiling from the bottom of the sea to the top of the mountains and just exploiting the system and driving to higher levels of illegal trade markets. And illegal trade markets doesn't end with only one product. For example, wildlife, tiger skin or a coral or anything. It has multiplier effects. It will reflect as into armed conflicts. It will, because most of the illegal trade markets happen with the barter system. So, for example, in the border districts of international border districts of India, we can sense it very clearly that there is a barter for illegal trade for wildlife items, and that trade is in exchange for arms and narcotics. So it is leading to a lot of other issues like social conflicts, narcotics, and even armed conflicts and so on. So now that why I highlighted that taking this morning is that in some way or other, we can definitely help to control this menace by avoiding buying this or not promoting the sale of this, or by advocating for not supporting these causes, even from buying a peacock feather to buying a leather jacket of a crocodile or anything, maybe from our market or from foreign markets. Now let's come back quickly to the ecosystem concerns. There is no need to say that ecosystems provide all sort of things we require, because these things are very quite known to us. But still, I emphasizing again, I think this emphasizing has to continue in our fight towards poverty, in our fight towards social justice, in our fight towards environment conservation, because we need to keep repeating these mundane things until we reach that destination of sustainability and development. Now, how it is critical to us? It is critical to the livelihoods of nearly like 1.6 billion people, which is like out of 8.7 or 9 billion people in the world. 1.6 billion are squarely depending on forest resources. And in our country also, the situation is not so different. In a population of 1.37, nearly 600 billion people are directly or indirectly dependent on forest resources, and around 300 million people are straight dependent on forest for inhabitation or livelihoods, or for forest-based support for their food security or livelihood security. So now one point I just wanted to highlight here is that a significant proportion of people living in the country are also counting wildlife as a valuable livelihood assets. This is one scenario which is prevailing, particularly in the Northeast. Some of the wildlife animals are even counted as their own livestock sort of option. So now, what is the emergency to protect these ecosystems? So as we know, we are now fighting hard to achieve all the 17 goals of the SDGs. But if we don't protect the ecosystems, many of the goals might not be achieved, because these goals are consequential to each other, and they're interconnected very much. So again, the emphasis is on protection and development, taking into consideration the requirements of ecosystem resilience and ecosystem-based supporting services for our sustainable development. Now, I'll simply state going to some of the technological options which have been adapted in some of the countries for wildlife conservation, because I was told that today's panel will be focusing more on the technology connect between the conservation and the, the synergy that can leverage from technology. So these are basically case study based tracks where first I will take through how we can harness technology to reduce poaching. This is a project done in South Africa, which is called a Connected Conservation Project, which we can very well Google and find out the details and how the modus operandi went forward for this. But as such, in short, it basically used a network of sensors and devices, support with the machine learning and camera traps and all. So this enabled the system to really stop, poaching as an output and rather conservation as an outcome. But how it worked, it actually provided real-time alerts to rangers with mobile devices whenever incursion takes place. We have a typical example of this in Kaziranga National Park and in Kana National Park also. We have installed the intelligent camera systems which can detect any object falling across the field of vision with more than 20 kilogram weight. And such data are intelligently analyzed. Of course, in our country, it is analyzed with the help of experts sitting on the monitor and then distinguished into a movement of a rockfall or a movement of a poacher. So the point is that we need such sort of technological interventions in our country with scalability. I hope the intelligent brains in our IITs and definitely look forward to this as a PPP or as a sort of startups, because these are hugely required to protect our resources. Why I'm saying again and again the same fact is that, of course, we have forest forces deployed across the country, but their reach is not so effective in the sense we don't have enough number of people to protect the vast resources. Even today, our country has 25% of its geographic area under forest and tree cover, which is an immense area. And we have only like one forest officer protecting for 20 to 30 square kilometers of the area, which is not at all making any sense. So the clear sense here is applied technology. Now we have the skill and abilities to do that and the opportunity as well. So develop options, develop projects in this area so that we can vastly apply them to protect our natural resources, as natural resources are very key for our sustainable development. And now I'll give another example again about fishery, which is a major resource often which is basically a public-private partnership. And it is all aiming to do fishing, to make fishing more sustainable and support the livelihoods of fisheries and fishing communities, because we know that the fish landing in our eastern and western coast has been sustainably, consistently reducing. So now we need to help them, and because of which our fishermen have been venturing into deep seas and often get caught in difficult weather conditions and at times, unfortunately, losing life sources. So Government of India has many schemes to support with the collaboration Navy and Coast Guard, but still directly addressing their causes will be much helpful to push sustainable fisheries. So the example here is all with the support of mobile operators and real-time data from NOVA. So here we can also harness the power of our data support from ISRO. And what they combined was they pulled in the parameters for weather, tides, wind speed, and vessel position and location of fish schools, and the sea surface along with the temperatures. Then they highlighted the areas where schools of fish are rich, and this is provided to the fishermen over digital devices. So on two counts, it helps first to push fishery towards more sustainability, ensuring fishermen's income. And secondly, it helps to control and monitor illegal fishery as well. And of course, they complemented this app with other educational features like coral reefs, conservation of marine biota, threat of pollution. So I guess we need to have such applications as well in our country, especially with respect to our both the cost to protect our fishery from unsustainable utilization as well as theft in our resources, which is also happening to some extent. Now coming to pollution management, Mr. Anand has already mentioned about it, the need of technological application there. So here I have drawn the example from Telefonica Brazil. So this is again an AI-based application, which is giving very accurate levels of air pollution to 24 to 28, 48 hours time frame. And this is helping local authorities to prevent escalations and emission. I guess for our cities, this is a very important thing which is required, because if we have such a sort of very user-friendly applications, we can plan actions at the RWA level, particularly in metropolitan cities, where the RWAs can be suitably funded or facilitated, and they can help people to respond more adaptively to such situations. And now I'll take another example for forest management. This is a project I have taken as a case example for our discussion. That's about rainforest guardians. Again, this project has gone wonderful and successful in the Philippines rainforest. So, though we also have such problems in our country. Basically, it is so innovative in the sense it captures the sound through sound in like normal process of sounds in rainforest, and then screens it through AI to detect variations, particularly to isolate illegal logging and animal poaching. This is quite possible and perhaps easy nowadays, because AI has advanced to that extent. And maybe we also need such sort of technological applications to sense our forest protection systems in the border areas, the international borders. Like I worked in Andaman Nicobar administration, where we had the problem of illegal poachers coming from Myanmar. We don't know, like it's very difficult to go into the outer islands and find out. But if we have some sort of device which can help us, even the presence, we can alert our enforcement agencies to protect our resources. Same is the case with the deep forest across the states. Many, like I highlighted in the very beginning about the animal poaching and illegal wildlife crimes. Getting a tiger out of the forest is very difficult, but people do succeed with that illegally. So these are few examples I picked up for start some sort of thinking in your mind, so that for our country as well, we can develop these products and help our natural resource conservation, and also for the neighboring countries. And maybe we have few huge markets in Africa and East Asia, especially to protect the natural resources, because as we already know, climate change response is the main challenge of today, along with the water scarcity. To meet both these ends, we need natural resources backed by very strong, resilient forest systems, maybe for water, maybe for food, maybe for carbon sequestration. So in this example for rainforest guardians, they could really conserve, like protect rather 30 million tons of carbon dioxide equivalent timber material from illegal poachers. So this is a direct output of that technology. So similarly, we can also have applications on the same lines of coral forests and mangrove forests, almost an adaptation of that. So many such adaptations have been made across the world after successful pilots. I guess we should pick up some of these and develop into very scalable products. And of course, that will hit the market, and not only in our country, but also in other parts of the world as well. So those were a few case studies I just selected for discussion. And of course, questions we can deal later. And thank you very much.
Thank you, sir. That was very insightful, and I'm pretty sure some of the researchers got some problem statements now itself. So, now moving forward, we have Dr. Vijaysai. So, Suraj, could you please share your screen?
Yeah. Am I audible, Deepti?
Yes, yes, you are.
Okay. Yeah. Thanks. Yeah. So a warm good morning to you all. My special thanks to Professor Indumathi for having me here. Of course, thanks to Deepti and Anthony for having organized this so well. And of course, thanks to all the participants today who have joined remotely on Sunday. Exciting discussions now, and great panel views that we are getting now. Raj in fact talked about the policies. Anand did mention about the priorities. Rajesh talked about the prescriptions, and then I'm actually looking little differently into the perspectives, because that's what is my domain, and I'll restrict it to only the technological aspects of water, and what should be our perspective and approach towards solving the problem, because the policymakers and the policy enforcement people have already expressed their views on how things have to be otherwise. Just going to the next slide, I just wanted to get your attention, and this is more of a thought, and we can skip the next slide and go to the next slide. Let's start going back in time, and this is to kind of see how our ancestors, looked at this universe. Next point here will be, of course, we all know that the entire universe was kind of seen in terms of the 5 elements, which is going to be the subtlest to the grossest one: earth, water, air, fire, and of course the ether. What happened, as we started looking into the science, and when you go to the next thing, we as scientists and technologists, took the 3 grossest elements: the earth, water, and gas, and then we turned into 118 elements, starting from hydrogen to organism, and then what happened in the process is that the land got affected, water got spoiled, and the air got affected here. So of course, we are talking about the mobile radiations and other things as well, which are having some deleterious effects, which need to be understood better. The question is that how should this be dealt? And that's where I'm calling this as more of a perspective and approach related things there. When we go to the next slide here, with this background, what happens with all this pollution happening and the environment getting affected is that definitely it's a cause of concern for all of us. It's tied up with our GDP. We got to spend more on our welfare and healthcare systems there. Of course, the agricultural yield also gets affected because of the pollution level going up. There is an increased death rate, which the media is reporting because of the pollution of land, water, and air. Aquatic life, get affected because of the increased level of discharges. So these are all the effects that we all know are something not very enjoyable. But the next point that we got to think in this perspective is that how we got to deal with this problem. So is it good to kind of regress from here and look back and retreat and to stop our development, right? I mean, that's because what we are essentially telling is that we have been advancing, we have been making development so fast, and this is leading to all these issues. And then my perspective or my thought in that direction is that we got to be progressive. We got to continue to progress. We got to, in fact, continue inventions. We got to, in fact, get to the next level of civilization that we can be part of. And but at the same time, we got to find a better solution to this problem. And the topic looked so exciting to me because it's not environmental engineering, but it's the engineering the environment, and that's the different thing there. So that's where we got to use the engineering and the technology and everything to fix the issues that are being created, and to find a meaningful way to sustain our life and start continuing to progress from where we have been. So that's the thought of what I in fact wanted to share. And to connect more to this thought, let's kind of look back in time, how the evolution has happened, as far as the human beings are concerned. So what was considered to be a way to survive way back, during the old Stone Age or the evolutionary stage, was the muscle power. So we all believed that the greater muscle power can help us to perform better. So this power concept essentially then went into the next stage when the string weapons were discovered, and then the fire was discovered, and then there are different forms of energy and the power as we started discovering. The life standard improved and the people started coming to the next level. Third thing is, where we kind of saw the, industrial revolution starting in 1700, and then where, the real discovery of the power essentially propelled our, life standards to the next level, and the life continued from there on. Today, when we talk about, our lifestyle, the energy becomes the, integral part of our life here. So the tallest structures, what we are thinking about, the connectivity, what we are living in today, and the automation, the level of automation that we are seeking to achieve, the space missions that we have undertaken, you name anything, and the advancements that we have been making, energy becomes an integral part of our lifestyle. So as we start creating more and more energy, then we saw the other ways of the challenges are cropping up, right? I mean, we talk about the rivers getting polluted, and then the air getting polluted, we see the land getting affected. So then many challenges will start coming up. But when there is an interesting perspective that somebody in 1960 by name Kardashev, who is a a scientist who gave to the whole evolution theory, and he said that look, I mean, we can kind of divide our civilization into civilization type 1, type 2, type 3, and type 4. So the type 1 civilization is the one which will be capable of exploiting all the energy that is going to be available on the surface of Earth. And this is called as kind of hypothetical perspective that the Kardashev in fact gave it. And the type 2 civilization is the one which is going to exploit energy beyond the Earth, and then it is going to extract energy from the solar system. Type 3 is one where it is the civilization which will extract energy from the galaxy, and type 4 is intergalactic. So that's where he put this scale, and he said that as we start making this progress in our civilization, so we got to migrate from type 1, type 2, type 3, and type 4. The question is, at what stage are we in today? So he says we are not even type 0. I mean, that time when he talked about, that means the amount of energy that we have been using, we have been deriving, we have been exploiting is not even, qualifies us to be in type 1. So according to his scale, as of today, we may be somewhere around 0.7 or 0.75. That's what it's being said. So having said that, that means that we have more to exploit, we have more to derive, we have more to use in terms of the available energy on the surface of the planet, and then evolve ourselves into type 1 civilization. Having said that, what it means is, what are we going to do as far as engineers and technology scientists are concerned? So I guess this is a dire need to look at this whole process very differently, because as we start progressing, we are going to pollute things, and otherwise we cannot, progress if the pollution continues. So these are all kind of conflicting results that we get to see here. So if we have to progress, then there has to be stream of engineers, aggressive engineers, engineers who are in pursuit of the progress, and will be continuously focusing to take us to the next level. At the same time, there must be the set of engineers who will be not just reactive but also proactive in terms of controlling the damages that this progress is going to bring in, be it through the circular economy, be it through the resource revolution, or be it through the newer inventions to contain these damages. So this has to be a progressive and not just reactive but a proactive approach, that a set of engineers that we need to have to kind of take a look into the next progress that we are going to make. So that is where the environmental engineering might have to take a different view. Of course, as we have been seeing and Deepti talked about it in earlier, this is going to be a highly interdisciplinary area. It's not just one set of engineering domain or the discipline is going to solve this, but it needs participation from several branches of engineering to fix this problem. Earlier speakers did talk about the coal industries, the steel industries, and the mining industries, the textile industries, and how they have actually caused problems to our resources, particularly the application here being water. So in the next slide, basically I wanted in fact to talk about few of the areas that we should be in fact focusing as far as these challenges are concerned. And I want to broadly classify them into water, wastewater, and industrial water, and tough to treat water here. So, when we talk about water today, the heavy metal, contamination has become a major menace now. We just talked about how Kaveri has been polluted with the report that IIT Madras published, and how the trace and the emerging contaminants, and particularly the heavy metals in water, have basically affected it. So we got to have better methods to detect various contaminants at various levels, quantify them, understand them, and identify the ways to treat them effectively. So that's definitely one area that we should all be focusing on as environmental engineers. This is quite interdisciplinary. Not just one discipline can go and claim to have a solution established on this. And then the next thing is, when we talk about the discipline identifying this trace contaminants, there are a lot of advanced instrumentation that is required, and then a lot of methodology development that has to happen. One has to be highly skilled to kind of detect this contaminant levels, but then at the same time, could we actually look at the cost-effective sensors in order to identify these trace contaminants, and then with a good amount of accuracy, and then use those sensors to treat the water better, is the next level of thoughts that we could have as far as the water is concerned. Wastewater, when the water gets treated, of course, we are talking about the biological process, the inorganic process, the physicochemical process. The sludge is an inevitable part there. But then when we talk about the sludge, particularly from the biological process, is it something which we can directly use it for application? The answer is no. There are a lot of pathogens that the sludge can carry, and then how to basically neutralize these pathogens so that we can use that more effectively defines the class A sludge. There are many dissolved heavy metals in the sludge that have to be recovered or removed before it's made applied in agricultural purpose. So what are those ways of treating the class A sludge? Could be a wastewater related problem. Of course, recalcitrant COD is a bigger challenge which is not biologically degradable. Then how do we basically render them to a usable form, and then be able to knock them off from the water is definitely another area there. Let's come to the industrial water. The whole focus that what is the industrial water today needs is an energy efficient solution, be it in terms of generating the revenue out of the water by treating it, or at least making it as efficient as energy neutral, if not energy positive. So that's the way in which it is going to be headed. And Anand did talk about the focus that the government is talking about hydrogen, and one of the areas that we can in fact look into from the waste to value perspective is also biohydrogen. I mean, if we come to the tough to treat water, there are innumerable problems that need to be addressed today, and the industries are struggling hard to make the treatment economically viable. Of course, you can have solution in whatever form, but if it is not economically viable, then it's going to be a challenge. So the color and the COD removal, the complex COD removal, and these are essentially the challenges that we have to be addressed from an industry perspective. Let's talk about the desalination, because so much of things are being done to the desalination, and then we are talking about deriving the usable water after the desalinating. But what do we do with the reject? Are we going to throw back into the ocean? Is that the safer way of managing it? What is happening to the aquatic life when it gets discharged back into the ocean in the same form? Is there a better way of recovering the material from the reject and then segregating them? So that's a very important and bigger area to be dealt, and that's where the focus in fact can be immense. So now we are in the digital world. We have been making excellent progress on all fronts. So definitely the digital solution will have an overarching ability to address the issues like measuring, monitoring, and maintaining the assets at its best possible level. And that's where the entire focus can be. Just on the last slide, I just wanted to talk about what L&T has been doing here. So I have just put a conceptual view of our building, because this building is yet to come up, but there is a massive investment the company is planning to make and build a technology center at Kanchipuram, which will be having the state-of-the-art facilities to conduct and carry the research in the water space. So it will have advanced analytical facilities and testing facilities, piloting facilities, and of course added with remote monitoring and control capabilities, aligning with the problems what I defined in the previous page. And this is exactly an interdisciplinary center where we will be having technologists, scientists, and also the engineers working together. And let's call it as a resource rejuvenation exercise. So that's where I wanted to get your attention and your inputs. And with that, I'll end my talk here.
Thank you, sir. Like, that was a really good information that we all got. And now let's move to the next speaker, Dr. Anant.
Hello. Very good morning, and thanks to Dr. Vijaysai for the awesome presentation, and thanks to all the other speakers as well. I also would like to thanks to Professor Indumathi, and obviously the energetic and dynamic the coordinator of research and connect team, the Dipti and Anthony. So today I'll talk on more precisely more on technical parts, like on chemistry and what chemical and what is important, and how it can be a waste to the environment and society as well. So basically my motto for today's talk is like to give an opportunity or problem areas also to the students, so they can think and they can work on it as a research as well. So if we see in the day-to-day life, we use the chemical more precisely, starting from our the mornings, let's say from the toothpaste to till we get to the bed. Recent, like in pandemic situation, we have seen the importance of pharmaceutical drugs and all these things. So it's really important to see the chemical. Yet it's the second part is it's the wastage. That's rightly said by Dr. Vijaysai. It has an adverse effect on the society, and the water get polluted and all these things. But how we can take the challenges? Okay, before this, just let me quickly go through the intro. So I have been in the industry like more than 10 years, more precisely with an oil field, and completed more than 300 open projects with and the R&D projects also more than 50 which commercialized. And I have been working as a senior scientist in Hollywood and in Saudi Aramco as well. So my main topic is like what in agriculture sector, what we can do. So there are a lot of wastage are there, right? So can we do something fruitful which can give a value to the farmers or a business opportunity as well, or some opportunity for the researcher in the oil field, on the petroleum sector, some e-waste and the plastic. So okay, so in chemical pollutants, so there are the industries, textile, the polymer, paints, and all these things. It generates a lot of wastage, and some companies are treating well, but some are they are simply putting into the wastage, and that goes to the river and that get polluted. So these are the type one. Then the groundwater, obviously, it is because of pesticides and the fertilizers from the farm. It goes to the groundwater. The third is surface water pollution. When I say surface water, so it's the surface on the, for example, it can be accidental or man-made as well. So in the recent, like in October, this was a news in California, there was a spillage of like 25,000 gallons of an oil has spilled. So you can think of like how much the aquatic life or aquatic like the fishes and the plants might have affected, right? So it has adverse effect on this environment. And the second type is like nutrient pollution. It is because of the excess amount of the nutrients which we are feeding to the farm that eventually it gets drains off and then goes to the rivers, and then it gets, like you can see this kind of the things which happens, like excess growth of algae and the aquatic other plants has got generated there, but then it can also hamper for the other systems. Another one is the microbiological. So the microbiological, like bacteria, viruses, and protozoa that are naturally occurring in the water, but that can lead for different diseases like cholera and diarrhea and all these things. And the another one is suspended matter. Suspended matters is also it's hampering on the oxygen depletion pollutions that get. So okay, let's take the first sector is an agriculture sector. So the current season is, I think, in our country is like they're producing the maize is the current soybean, and maize is the current crops. So if we see this on the right hand top side, this is an corn cob. So this corn cob, people, what they do is simply the waste, right? So they can simply throw it or use it for the burning application. And in industry also, I guess some people are using it for the boiler. That's they call it like bricks, the compound bricks, I guess, right? They are using this kind of things. But besides that, can we do, being a researcher, can we do something, a value added product out of it? So yes, it has a chances and it has an opportunity. So what we can do is, so number one is we can prepare, we can synthesize like silicon nanoparticle from the corn cob, right? There are systematic procedures and the way to manufacture it. And it can be used in the concrete industry, in the rubber industry, in the plastic industry, in the agriculture sector as well, in the paint as well. It has an diverse of applications of this silicon nanoparticle. So what second we can do it, like choline chloride. So you might have heard about these things. This is widely used in the feed for the chickens. In the poultry industry, what people do is like for the fast growth of the chickens, they're injecting a lot of different hormones, but it has an adverse effect on the body because we are eating that, right? So in order to stop these things, so this is a very good food for them to get the fast growth as well. So second is like in oil field, it can be used in the hydraulic fracturing or the drilling fracturing is widely used in the oil field industry, and it can also used in the antifreeze for different kind of the solvent not to get freeze, more precisely in a European country, this can be used. All right. So the third one is the fur fuel. The fur fuel is the things which mostly used in the pharmaceutical industries or in the fragrance and agrochemical for like fungicides and all that sort of things has been used. This is again, it has a method, scientific method, to make it or isolate it or to synthesize it from the corn cob. Right. So if we see the market potential of these, so in the 2019, it was like $550 million. And in the potential market in 2024, if we see the forecast is around $700 million. So my point here, or I would like to give the message here is, if we see the raw material or starting material is simply corn cob. What we are doing is simply we are burning it either in the farm or we are making some bricks of these things, and it is using for the boiler applications. But can we think in such a way, in a different manner, and can we make a value-added product out of it? So being a researcher or a scientist, I think we should have this kind of an approach. And there are a lot of other agriculture terminology and other wastes also. So in the country, we should see on that part as well. I'm just putting here an example into one. So the second sector is an oil field sector. So in oil field, just to give you an idea, a brief idea about oil fields. So it is very similar like to drilling the water well. So only the difference is these kind of an oil well are like 500 meters deep to 5,000 meters the deep. So horizontally as well as the vertically, right? So in case of so by like 5,000 meters, it has to go on for the more availability of water. It goes horizontally as well, and it requires a lot of different kind of chemical. For example, the drilling fluid chemicals. So in order to get drill or this kind of the stones or mud is get wet and remove it to the subsurface, it needs the drilling fluids, and it requires hundreds and hundred different chemicals and factors and systems which is required. All right, the few are like emulsifiers, cell inhibitor, loss circulation materials are few of them. The second, once it gets drilled, and it needs like cementing in order to not to collapse that, it needs cementing and then fracturing, because once it get the cementing, then you need to fracture it in order to get the oil out of it, right? And then in order to get enhance the oil, then that comes a picture like EOR, that's enhanced oil recovery. So what people or the oil field expert or being a scientist, what they use is like they have to check it with an environment also, because when the oil exploration company brings the oil, they don't only brings the oil. Along with the oil, it comes some water, some sludge, and many other impurities as well. Whatever we are pumping inside, it comes out of it as well. So we have to take care with our environment. For that matter, what we do is, this is, you see, this is the GOR. So we are pumping the GOR gum based fracturing fluid. Okay, this is a natural the fracturing fluid, which this is the polymer, actually the polymer which we are making the solution and pumping inside. So up to get the job done, it is okay, it will perform. Once the job gets done, then it will forms like a water, very thin, and then it can come out as a natural sources. So this kind of things we have to consider. So because otherwise it will be so a lot of hampering in the environment, the things will happen. But again, what is the drawback? So this biodegradable, this GOR gum and all these things, it has a drawback, like it is not stable at high temperature. When we go down here and here, so at temperature increases. So the GOR gum is not stable at higher temperature, let's say above than 300 degrees Fahrenheit and all these things, it is not stable. So what we can do is, so we need to go for the polymer, synthetic polymer. So the next picture is like how we can modify this synthetic polymer in a smart way. Is there any kind of an opportunity for the researcher or the scientist, to think something differently? Yes, it has chances. Like stimuli, when I say stimuli, so there are different type of stimulus like temperature, light, magnetic, and all these things. When you apply the materials or the molecules, it can reversibly or irreversibly, it can swell and deswell, like increase the size. You might have seen the hydrogel, it is very similar like that. All right. So what we can do with these things? Can we use this for the oil field application or for medical or for other? Yes. So this is a typical synthetic route by which we can synthesize these. And what is the application? How we can do it? Okay, just look at on the right hand side, the bottom, this picture. So this is the drill bit. Okay, so this, just consider this like 5,000 meter deep, and this is the drilling along with the mud. Okay, so and this is the fracture. So you have seen in the last slide, there are a lot of different fracturing fluids and chemical which we are pumping, but because of this fracture and fissures, so the materials is get lost here. So now the opportunity or the problem area here is two. Number one is how we can detect where my mud is going on, where my mud is getting lost. Number one. Number two is how I can stop these things. Is there any way? Yes, there is a way. How? So as I told in earlier also, as we go down from surface to subsurface, the temperature is increases. And this is the molecule which we have synthesized. This is something temperature sensitive. When I say temperature sensitive, at room temperature, it is just like normal water. And when it goes, when it sees like above 100 degrees Celsius temperature or 90 something, it will increase, it's like expand. So what eventually will happen? It will block these kind of things. When you are mixing this chemical, the polymer along with this mud, that will go somewhere here and then block. So there will be no further losses of this your value added or the products, let's say drilling or other products will not lost. So in this way, we have to think out and then how we can do in an innovative way. So this is number one. Number two, the problem is still unanswered. Now I have solved the material is getting lost, but how I can get it, come to know that where I'm getting the lost this material, right? Because this is something inside, we cannot see through, right? There is no way to see it. So in order to do that, so what we have done, this is I have done in my postdoctoral in the coast actually. So we were working for an Aramco, Saudi Aramco, the company. So that's a giant company in the world for oil exploration. So we gave the support to them on this problem, and we published the patents also on the US patent on this. So it was a magnetic sensitive materials embedded along with some drilling fluid. This is drilling fluid, but the problem is these magnetic particles that are not stable in the system, right? In order to make a system, we have to use some polymeric and surfactant-based system, which should be stable at temperature, at particular temperature, right? And perform the job as well. So now what will happen? You can easily get track where my fluid is moving, right? Because of this magnetic movability and traceability. You have this an opportunity. So this way we have solved the second problem as well. Number one is the fluid loss, and number two is the detection of the mud where it is getting lost. Now the third challenge in the industry, oil industry, is I'm sure you guys must be aware about the dangerous of an S2S, but let me tell for those who are not aware, the S2S is a deadly gases. If you are exposed like up to 500 or 700 ppm, meaning 0.05 to 0.07%, it will simply take 30 seconds to 60 seconds to get die. Clear? So this is what the dangerous of this S2S is. And there are along with the oils, it always comes with different gases, no matter whether it is S2S or other gases, it comes to along with the that oil. So we need to track where my S2S is or how I can detect it. So for that matter, the fluorescent materials on the left hand side, if you see, bear with me, those who are not from the technical background, but I just would like to give the idea how it is working, you know, so for the student more precisely. So this is on left hand side, this is a non-fluorescent molecule. You can see it here, N and OH. When it sees the S2S gas, it get reacted and it converted into the fluorescent molecules. All right. And then this way you can very easily get analyze where, because of due to this fluorescent instrument, you can analyze where the S2S gas is. So this is again the second challenges. Like this, there are a lot of other challenges in the industry. Like as the corrosion, the problem. So corrosion problem is not only limited to the oil field only, but it has in the water also, in the water industry as well, and a lot of other industry. This has a severe problem. So we have worked more than 200 projects on oil field on the corrosion. So basically it is all because of whatever the chemicals like HCl and other organic acid we are pumping, because of temperature also it get corroded. So in order to stop it, we have to find something environmental friendly, the coating materials, which should not get corroded. So this is also a problem area to look into. So the second problem area is there are a lot of chemicals which we are using in this field. So can we make, as I said, for the environmental friendly, let's say gorgon, I gave the example, right? So it has some temperature sensitivity issue. So can we make something which is stable at high temperature, high pressure, but it should be a combination with along with like your synthetic and natural. So it will stable, it will perform the job as well, and that will be not environmentally dangerous as it is only the synthetic. So this area is also, or this is also opportunity for the students or researchers they can look into. The third one is, as I already mentioned, this is in loss circulation materials is still open because the fraction is from 0.5 mm to 5 centimeter of sizes. So it is really difficult to manage with different materials. So this problem is still open in the industry, and this is still challenging. So you can come up with some solutions so which can survive, so like you can avoid the losses of this mud and all those things. And this is again the picture of this. There are always incidences happens like oil spillage and all those things, so which damage the system. So how we can take care with the environment to recover with the oil spill. And in cementing also, a lot of the gases like corrosive gases is also get evolved, which corrode the pipes, which corrode the cement, and eventually it get break down and crackings like this, and then the losses of your oil is happening. So these are the few kind of the areas where you guys can take into. There are thousands of others as well. So the next one is, this is what we have seen is an oil field, but the another, looking toward the fast growth of the population growth and the global growth, we have to see for the alternative resources, right? So India and many other countries have already started to use the e-vehicle and all these things. So we have to see this perspective, looking towards like 2030 or something like 10 years ahead. There will be a lot of the batteries, lithium batteries and all those things. So how we can manage that particular problem? So do we have a solution for that? Are we prepared for that? We are using, yes, we are going ahead for the solar alternative sources and electronic the sources and all those things. That's true, but are we prepared to handle these e-wastes and all these things? Because it has really, believe me, it has really a vast and drastic dangerous effect on the human system. For example, in the neurological system, respiratory system, in the digestive system, it has the really dangerous problem. So why it is happening? It is simply happening because of the toxic materials which we are using inside of these electronic things. Let's say lead, zinc, flame retardants, the bariums and all these things. These are using in this kind of materials. So what solution we do have for this problem? So if we see this Tokyo Olympic 2020 medals, India also got the one medal, gold medal. A lot of other countries also got a medal. But are we aware about how this gold medal is made? The Japanese scientists and these people, these folks has, what they made is they use these electronic devices, let's say mobile, and they recover or recycle the gold out of it and then making this kind of this gold medal from it. Can we do such kind of thing in our country? Yes, we can do, right? So I felt it's like as an inspiration for us as well. Like we do have an opportunity to extract this kind of a metal, not only the gold, it has some other metals also, value-added other metals, let's say silvers and others. That can be, we can develop a method to extract it or something alternatives that can be also done. Another problem area is the plastic. It is, I know it is unconventional and it is since long, but I think it is still unanswered. Some people are using it like alternative recycle, first generation, second generation and all, but still again, it is in wastage, right? So this picture, you can see it like how it is hampering. So it's really hampering a lot on the human being and the other animals of Earth. So you know what, it requires like 400 of an year to get degraded. So this is not that simple, like 8 to 10 generations will get died just to get degraded of this polymer. Can we have an alternative solution for this? Because in 2019, before pandemic situations, I have the data like it shows 6.6 lakh tons of plastic wastage in India, alone country. So when think about the global number, my God, this is super high. How we can deal with this situation? So can we use like something which is bioplastic, which is meaning like maybe from vegetable or starch from other sources, right? So I think this has an opportunity. In the agriculture sector also, some of those who are from agriculture, they might have seen this. It's called mulching paper. Once it gets used, people are simply throwing as such in the farm. It gets. Can we do this bioplastic for this and get eventually degrade automatically? So think of this. This is, I think, a problem area. I'll take a few more minutes, maybe 2 or 3 minutes, just to get you through how the industry is getting affected because of the pollutions. On the right hand side, if you see this industry is getting the pollutions through air or through water, and it has a systematic effluent treatment plan. Many companies, I believe, they are following this plan, and then they are making this water and reusing it for the irrigation, maybe inside or for the domestic uses and all these things. But those who are not following, they are on the left hand side on the bottom. You can see this picture. This is what is the situation, right? Then think of how much the effect it will be on the aquatic life. Don't forget it. We're simply seeing the current scenario or immediate scenario, but look at this. We are also eating this fish and all these things. So it get automatically or indirectly come to our body as well. So we are simply throwing this kind of chemicals and all these things in the water, but don't forget it is hampering or rebacking or rebouncing to you as well. So in the water quality, what it has, so the earlier speaker has covered some, but I'll just take you overview through this. So it has like different, maybe the chemicals, radioactive chemicals and biological the things we can check it. For example, in the biology, BOD, bacteriologicals, and the phytoplanktons has been taken care. We can see that as well in organic and inorganic and in physical. So in organic, there are like phenols and other oils and the greases are there. So that need to be analyzed, and that can be analyzed with different technologies as well. So, and then physical parameter, let's say we can test it with like temperature, taste, conductivity, turbidity, and all those things. In toxic metals, this is the most dangerous. I think Dr. Vijaysai has already covered a few on how the dangerous the toxic materials and all these things. So this also we have to take care. And in organics, let's say calcium, magnesium, and phosphate, and all these things. What instrument we using? So I'm just giving a brief idea, like the pH meter, conductivity meters, TDS, and elemental analysis like ICP, OES, and all these things are using for this. But it again vary what kind of pollutions or what kind of the elements are there. And as per that, we can also use like FTIR for the advancement I'm talking about, SPLC, polymer gel permeable chromatography, and all these things. So these are the few things which we can use it. In summary, I think I have covered which what types of different the pollution, and in agriculture, I already told, like I gave the example, one example of Concord, and you can search for the other opportunity and look at your nearby areas. What you can do something in order to contribute to recover for the wastage and to add value-added product out of it. In the petroleum, I have shown you the ample open problem opportunities you can take into look into it. In the e-wastage, this is also an immediate challenge, as well as down the line of 10 years also it would be worst. So before getting worst, so I think it would be good for the researchers to look into, and the plastic is also still there unanswered. So with this, I would like to thanks everyone and organizers and speakers and everyone for the these things. So thanks a lot. Yeah.
Thank you, sir. That was quite insightful and very technical too. So I guess especially the people with the chemical background would have certainly made use of it too. So now the interesting part of this entire event is about to start. Indumathi ma'am would be taking control of the speech. So ma'am.
Yes, Deepthi.
Yes.
Can you hear me?
Yes, we can. So all the panelists can switch on their videos. So now ma'am would be proceeding to have a conversation with all of them.
Yeah, sure. Thank you. First of all, I would like to thank the entire panel. Very, very well selected panel from multiple domains, from the government, from the industry, from the environment sector in particular. And it was actually, I would say, we should have had 5 sessions instead of packing them all. There was so much information packed in every talk. It is difficult to digest even for me working in this environmental area. I'm sure the recordings are there for the students to go back and relook at it. So I would like to quickly summarize first the speakers briefly, what the speakers have put together. So it gives us an input for further discussion, and I can also pose some of my questions, and there are also questions which have come to us from the audience. So from the government side, we heard very encouraging initiatives, both from Raj and also Rajesh. It was quite encouraging to see the initiatives of the government, particularly looking at the district environment management plan, and also looking at, apart from pollution, the environmental impact assessment to prevent rather than remediate. Particularly the district environment plan was something which is new. I'm hearing it for the first time. We would like to see how we can help work with the government and come up with such plans. Particularly, the other thing I was impressed with is with what the corporate is doing. I think Anand Krishnamurthy comprehensively put together what's happening in the industry side, along with I think Vijaysai also talked about what is happening from the L&T side, what initiatives they are taking, and also Anant from the oil sector side. Although we know about the problems, we have been hearing about these problems over and over again. Solutions are the ones we are looking for. I think both from the government side, industry side, I saw the need for solutions from which we can actually play a role as academicians with the huge student population here who are hungry for solving such problems. I think we have a big role to play in addressing the needs of the industry and also the government. So I just quickly, I wanted to show I summarized it so that we can have all in one place. Can you see my screen?
Not yet, ma'am.
Get to load, ma'am. Not yet.
Yeah. Sharing it.
Yeah, exactly.
Yeah. So that we heard about all the initiatives, problems. We also heard about their needs. Particularly the lack of skills was something which was coming out from many of the speakers, and the need for capacity building in the environment area, which I have also felt for a long time. There is a disconnect between what we are doing, what we are teaching, who we are teaching, and who are the players out there in the field. When I go for different industrial visits and when I talk to government people, we don't see this translating there where the actual problems are there and where they want people. So somehow I think that gap needs to be filled. I heard that from all the speakers. There is a need for, apart from skill sets, there's a need for new technology with all the innovations happening. We need sector-specific innovations. We heard from multiple sectors there. So it will be good to compile and prepare a compendium of needs for technology in multiple sectors, and that can be disseminated to the academy. There are where people are there, the human resources are there, the knowledge is there, the expertise is there. And the other thing is I felt based on my experience and also from the speakers is the need for entrepreneurs. There are innovation challenges out there for which we need, particularly the research happening and the projects happening in academia should translate into commercialized solutions. Okay, so we need to have entrepreneurs in the environmental area. And it's not just a civil engineering, environmental engineering domain, like how it is structured now. It is an interdisciplinary domain. Okay, we need mechanical engineers, electrical engineers, artificial intelligence, we just heard, sensors, biologists, okay, biodiversity authorities, geologists. So all kinds of people should play a role in environment management. And so we need to build, probably we need to build a program which is interdisciplinary in nature, which can address these problems. And the other thing is, which came out, is there is a lack of awareness of the technology needs of industries. We are doing our own research here, whereas the needs are different, like I said before. And also Mr. Raj also pointed about the lack of impact studies, environmental impact studies of product development. The industry only looks at products, profits. What is the impact? What is the impact of, let's say, mining industry? It's all there in paper, but the actual impact studies needs to be reworked on, okay, so that it reaches the common people who are living in that community. Lack of health, relation to health and pollution is missing. Okay, so, but the positive thing is there is a huge opportunity which is coming up. A lot of awareness has started coming up with corporates, lots of rules, and particularly the sustainability reporting, SEBI's BRSR, Anand that pointed out, is all an opening, an opportunity is opening up in corporates, which needs to be tapped. Okay? And how do we address all this? To put, I just summarized the thoughts which came out here. So at the policy level, still there can be more changes which can happen, particularly in the implementation side. We heard about NGT's powers, Pollution Control Board's powers, okay, but often they are not equipped with technology, technical inputs on a case-specific basis. I had been there to multiple trials in NGT, where there is only one technical expert, and there's not enough time. The number of cases are huge. There's not enough time. There's not enough expertise. It's just a whole bunch. The entire setup is all lawyers, okay, and one technical person addressing all that. And there is not enough technical input which goes into decision making. That is what I felt. And so we need to build that whole system to support the NGT. We need more technical people. Even pollution control boards are understaffed, given the amount of problems we have. So we need a huge capacity building for these policy changes to be enabled. And of course, skill development, awareness at school, college, public, like how awareness for COVID came. We need to have awareness. We need to hammer this idea, how environment, industry, development, they're all linked to health, and how it comes back to us if we don't do the right things. So from the academic side, we could develop new programs, new streams. There was a minor stream in sustainability a while ago, which is not existing. Maybe we should go, considering the demand, probably we should go and develop new curriculum, new streams, and bring in all the other sectors to environmental area. Okay, and already we have innovation space in IIT like Nirman and our incubation center. Probably we need to create a new space for environment and sustainability related technology. Carbon Zero Challenge is one such initiative. And so we need more like that, and kind of channel all the engineering fields to think and develop innovation, new innovation, and become entrepreneurs in the environmental domain. So with that, I think I will stop, and I will probably reach out to the Q&A session from the audience first, and then I can add my own questions. Do we have, I think I see one in the chat box. which is only a comment. The government policy to be strengthened to reduce pollution control through Central Pollution Control Board and State Pollution Control Board. Are there any other questions from your side, Deepthi? Or can we look at the questions which were posed earlier?
Yes, ma'am, you can go ahead with that.
Okay, so this is probably posed to Mr. Rajesh. Considering the emergency of climate change, to what extent is the livestock farming contributing to this threat? Or should we change how vegan lifestyle or a plant-based lifestyle? This is a very general question. How can it contribute to climate change?
Yeah, so yes, that's a very typical concern in the climate change response, the emissions from the livestock sector and agriculture sector. So if you put on a macro scale, these two will contribute around 25% of total emissions, it's such. But now the solution side is like we also have a tremendous, bearing on animal husbandry based economic support. So we cannot do away with animal husbandry. So the way forward will be to look forward for more climate resilient animal husbandry practices. Like, okay, we'll go for an improved breed, then we will go for a better stall feeding, and also will also support with the micronutrients. And similarly, slowly we can move over to certain like plant-based proteins, like Singapore has has brought out with a new form of meat, so which is as good as normal animal meat. So we need to think on those directions in a gradual way, but immediate requirement will be to adapt our economy to this challenge. That is through a sort of climate resilient animal husbandry practices involving better breeds, high productive breeds, better pasture lands, protecting their pastures, especially for the people in the hilly economies where they have a lot of livestock dependency, and these livestock graze on natural forest or open grasslands. So with the climate change, these grasslands productivity might decline. So we need to restore. We need to put in measures to secure that productivity. Side by side, we should also move slowly to other forms of proteins, so mainly plant-based or synthetic proteins.
Yeah.
Thank you.
Sure. Yeah, there is so much, I think, to contribute to climate change. This will definitely play a huge role. Apart from the other major contributors we know are the energy sector and other things, but this is definitely going to play a role. Yeah. Okay, we'll move on to the next question. This is to Raj. I want to know how the range of difficulty in executing a people welfare project when compared to a social cause like climate change and pollution control. How is it different?
I think sensitizing people, and bringing people together is a difficult thing when it comes to tackling environmental challenges. For example, if you're building an infrastructure project, let's say you're building a road, you're acquiring land for the road, you may have some difficulty in bringing elected representatives on the board, but when you show them the future, when you tell them that once the road is made, I mean, the ease of transport and the development that it can bring to the place, they generally come on board. But when it comes to environmental challenges, it's pretty difficult. I mean, lack of that's what I mentioned. Like, there is no direct, like easily understandable data where we can tell them that if we don't stop this, or if we don't go ahead and do this solid waste project, this is the quantifiable loss to the villages, or this is the impact on the public health in this region. I think that's where I think there's a lot of research needs to happen, or maybe the research is happening, but it's not being made available to the people on the ground. So that's where I believe things are pretty different when it comes to taking up projects which are more environmentally oriented. And now, right now, as of now, we are only taking up environmental projects because of a court case or some kind of a compliance that we need for under a particular act. It never happens that we take up a scheme like a developmental scheme or a welfare scheme that we proactively take it up. I mean that doesn't happen. I mean, at least the part of the part of the country that I'm working, it doesn't happen naturally.
Yeah, very true. I think we are only reactive, not proactive. Well said. And there is a disconnect. There is definitely a disconnect between what is required on ground, because there is not enough communication. That is what I feel. We get to meet as faculty, we get to be invited in these committees, government committees. So whenever there is a need, like you said, no, there is a case or there is a decision they have to take and they cannot take it alone. And we get 20-minute presentation and there's no follow-up after that. I think those can be easily mended at the government level. Engage with researchers or academicians who are having knowledge in that domain area for a longer duration, maybe right from the project conception stage. I can tell that from my experience with Chennai Corporation also. So as a technical expert committee, you just go and attend a presentation and there's very little time for you to even think and give your response. Often I find that is the gap. If we had engaged with them right from the tender call, and there the inputs could have been given in a more effective way and the whole proposals would have been in a much different level. So probably this is a request. I think all my colleagues also share this. We are often helpless because we would like to play a big role and it's not happening. Things are beyond our control at some point. So thank you. We would like to see more proactive engagement in future. Shall we move on to the next question? I think this is to Anand. What is the scope of sustainability for engineers? What should research be equipped when it comes to sustainability? I think he's asking for for all other engineers. How is sustainability?
Now, first of all, sustainability is quite an interdisciplinary field. Now, when it comes to, and I'm talking more from a sustainability challenge that a corporate or a government is trying to address. So for engineers, well, definitely there are technical elements to be seen. If it's a, say, carbon emissions problem or a water problem or a waste problem, there are the technical elements. But even moving beyond that, I think there could be issues around economics. There could be issues around transport, disposal. I mean, there are a lot of constraints that people work with in addressing challenges of sustainability. I think first and foremost, just the ability to understand what the problem is and have a process around solving that problem. I think it's most important. That's where I think engineers can do quite well try solving a problem from first principles, and that's where the sustainability field will offer a lot of opportunities for engineers, whether it's environmental engineers, civil engineers, chemical engineers, mechanical engineers. I mean, for example, I'm right now we are working with an organization that does bio-CNG from waste, and they have while it's a anaerobic digestion problem that's at the core of it, but they also have to deal with the waste that cannot be processed in that particular reactor. So, I mean, what do you do with the plastic waste that is coming out of it, or the biomedical waste that is coming out of it? So there you need mechanical engineers to design a segregation system, somebody else to do some other kind of a processing system. So the problems are quite widespread, and we need to look at case specific basis as to where engineers can play a role. I hope I answered that.
Yeah, I think you did. The next question would be to Dr. Vijay. Talks about water. So I'm posing it to you. India ranks 120 out of 122 in the recently published Global Water Index. What are your thoughts on this? What changes will make you to make to improve? Will you make to improve this ranking? Maybe you can tell from the point of view of L&T.
No, that's a fantastic question and very well, posed. Well, I mean, there are multiple, layers to the whole, way that it is structured. I don't think, we lack in terms of policies. That's one thing which is grossly misunderstood. In fact, some of the norms and some of the regulations are much tighter, compared to even the European standards. Even our IS 10500 code talks about heavy metals and the contaminant levels, how they have to be restricted. Our IS 40543 is even much stringent in terms of the lead levels and the acceptable levels of heavy metals that have to be looked into the bottled water. So from a policy perspective, I personally feel that we are well covered, and of course the whole challenge will be from an implementation standpoint. The economy has to support it. The priorities of the people have to support it. It's driven by the awareness in the community to ask for something more stringent from the implementation perspective, not from the policy perspective there. From those standpoint, we have some of the we have some more to catch up, and then we got to work in those directions. And the next thing is, what is possibly considered to be a solution in a developed economy cannot be directly lifted and then implemented here. So we got to, in fact, as you rightly pointed out, that the academic institutions have to chime in, and the local bodies have to join their hands, and we got to develop the solutions that are relevant to the geography and the particular demography we have, and then we got to come out with a right way to solve the problem. And that's where I think we can definitely do more.
Thank you. Yeah, I agree with you. There's so much to do. I think a forum like this is a great beginning.
Absolutely. Yeah.
The needs has to be communicated, and similarly what is happening in the academic institutes needs to be communicated, and we need to come in that interface somewhere in between. I wanted to mention about one program taken up by the IIT before the COVID. We reached out to MPs, the member of parliament. They have some funding. So we reached out to them and asked them to come up with problems in their constituencies. And a bunch of faculty who were interested in working in this area were brought into that meeting. And then we understood their problems, and we deputed a bunch of students to each of these villages. At village level, we were trying to work with them, who went and actually worked in the field and identified the problem and what could be the engineering interventions. So the MP fund was going to facilitate implementation of such schemes. They came back and developed solutions here and wanted to go back and implement it. Unfortunately, COVID stopped the implementation. But these are the initiatives which will actually make a difference. And also the innovation space, that's the other area where new technology can be developed based on the needs of the industry, as rightly pointed out by our speaker. So with this, I would like to get some closing remarks from a few of you. What is that which IIT can do apart? These are the two things which I can think of. To be more specific, we can even go to the next level and take this up with our admin and have more closed room discussion with some of the government and the industry people out there. Any closing remarks from the speakers and panelists?
I would like to say that, yes, as we just discussed, we needed an enhanced level of participation in the planning and implementation, and that to have to be based on evidence and the science. So with that, perhaps we will be able to use our scarce resources and move forward faster in our endeavor to become a developed country. And particularly for the time frame up to 2030, we are like fast tracking all actions to meet the sustainable development goals. So more than ever in the past, this is the most pressing time to engage with all our faculties and abilities in the society to achieve them. Thank you.
Thank you. Mr. Anand?
Yeah, so what I feel a leading institution like IIT Madras can do is to embed sustainability in their own practices. For example, if you're coming up with a new building, how can you set an example for the world of using sustainable architecture, sustainable bricks, sustainable building materials, wastewater treatment? What can you do with the campus? It's like 400-500 acres. I mean, there is so much to do within the campus to embed sustainability. If you're building a new road, can you try some plastic waste road and showcase it as an example for the world? If you're if rainwater harvesting, can it be the best rainwater harvesting system that the world has seen that's been implemented within IIT Madras? So my only point here is that there is much that can be done within IIT to showcase for the world in the area of sustainability.
I agree with you. We are already making a lot of initiatives in this direction. We, particularly in the water, we are completely going towards reducing our dependence on the outside water supply by treating our wastewater, reusing it, and also replenishing our own lake and using it back again for water supply, apart from flushing, gardening, and all those requirements. Solid waste also, a lot of initiatives are happening. I'll be happy to send you some more information about it, but there's a lot to do, lot more to do. I agree with you. We have solar rooftops, but sustainable building as a concept, I think we can work more in that direction. Any other remarks?
I just had one point to add here, ma'am, and that is more on spreading the awareness. That's where I guess the academic and industries can come together. We are in a situation where the food and water, are supposed to be provided to the huge population that we have, and somewhere there are chances of cutting the corners. We are cost conscious nation, definitely, but we got to become quality conscious too, and that's where the awareness spreading missions can definitely help people to realize the importance of being more quality oriented. And then and of course it comes in terms of paying some more money to avail that quality, and then once that is there, through articles, through publications, through certain missions, so we should be then able to build those relevant solutions to make it available for public. So that's how it has to probably progress, and both academia and industry can join hands to kind of spread the awareness better.
Yeah, thank you. I think, to really see a change in the way students look at environment and sustainability beyond just a course, I think we need to create a job market. That is the biggest gap which is there right now. Everybody talks about sustainability, talks about environment. There's so much happening, awareness at the school level. But when it comes to even college streams and branches of engineering or environmental sciences, there are not many takers. Even for civil, you think there's only the last rankers come to civil. And then unfortunately, right, there, because in spite of this huge potential, which we all talked about, I don't think the youngsters realize that there is a huge potential in this area. Okay. At the master's level also, environment gets only the last preference. People go for structures and other area, even chemical engineering, process industry, dominates than environmental stream. So if that is because of the disconnect again between the job demand, job market, and the production. Many environmental engineers, civil engineers, they don't stick to the same field because of this. So that has to be done at a policy level. We need to translate this demand into jobs both in industry side, the government side, and provide and promote environmental entrepreneurs. So many of the environmental industry have actually not been able to survive because of this. There is always a there is an experience component in the bid. So the new environmental companies cannot even compete. So those things have to change. Then we can see a real change, and then the youngsters, the bright young minds will be attracted towards this field, which can make a big impact on ground.
What you say is true, ma'am. It's correct. That's the reality, but hopefully it will change. Yeah, let's hope this will give an avenue to all that, and the students listening will take up environment, sustainability in their future career, because it is, as we said, it's an interdisciplinary area. Anybody can jump into this. There is opportunity for all the different streams of engineering, science, health, public health. A lot of different people can play a role. So I really thank the organizers for this event. We should have more such events.
I think I'd like to add a bit, ma'am.
Yeah.
Just a passing remark, like what you mentioned about the interest in environmental engineering. But I see a good change. Things are changing for the better. Because when I took the UPSC exam, there was no separate section of environment and ecology. And now there's a huge part of the UPSC exam. I think many students, youngsters, like they are planning to take up government service or even start a company in their own, in their region, in their state, in their town. I believe it's getting better, and slowly it's going to pick up. And like I told you, the great convergence that is happening between traditional infrastructure schemes and the clean water schemes now, like we have the Jal Jeevan Mission, huge investments are coming in infrastructure. And across the world, I mean, post-COVID, there will be a huge push for infrastructure to boost the economy. And I believe it's the right time. I think the students who are like about to make the decision, I believe, I think they should opt for the environmental engineering.
Yeah, thank you. I think we'll end with that positive note. So over to you, Deepti.
Okay, so thank you, ma'am. So I want to thank all the panelists. So, but the thing is, we were getting a lot of questions, and I don't think this session would cover it, but I'll send the questions that was given to each of you like separately, so that the scholars and the students have an opportunity to learn more about it. But in a final note, I want to just mention one question. That question is to Anand, Dr. Anand Ghumare. So there was a specific question on, is there a skill difference from the students that you see in India and abroad regarding the environmental area? So is there any specific set that the students here need to reciprocate in some way?
Okay, that's a good question. I think each university or each country has their own, flavors of in academy and all these things. So what I observed in abroad, being in US, in United States, and like in Texas also, and in Middle East as well, and the coast. So they guys are more like the industry oriented. They take the actual real problems, right? So it is, since from their education, they more focus on the industrial solution. For example, in Canada, so there were one of my colleagues or advisor was actually working on the oil and gas projects actually, and the student is also working on that wastage and their treatment, right? So actually these things is should be done by the many things in case the company is doing, but in the US and the Canada, they are giving this topic to the student. So it is in their system, where I think it is important for us also to take this message and to inculcate this kind of topics to the researchers. As Professor Indumathi ma'am is also rightly said, there are not ample open opportunities available for the environmentalist. But I think to this note, I would like to say that so Mr. Raj has also rightly said things is changing, and I agree. So the things are changing, and nowadays, after COVID as well, the country has given a lot of importance for the health and the environment as well. So the policy is changing. So I think we have to utilize these things and then get enrolled to the environment, and slowly it will come to the opportunity in India and the student. But I think we being academician or industrialist, we have to give this opportunity to student, motivate them and involve them to the actual environmental system. So the answer for your question is yes, there is a different bit. As I said, based on the each country, it has a different flavor, and we are also doing a bit okay or a bit good being a researcher. But I think there is a scope for us to get involved more actively in the environment. Yeah.
Thank you, Dr. Anand. So whatever you guys concluded on, that was like one of the most question that was reflected in our QA. So like, for example, I can cite one. What do you think IIT Madras as an institute can do to encourage more students to look into jobs and innovations in environmental and energy sector? Another one was, personally, I feel that there is less visibility and awareness or even opportunities in this area that are put upon internship portals or placement portals, even though we are interested. So I hope this session is the seed to something better and new, where a whole set of bright engineers can solve the problem statements that is around all the world, and oil, water, soil, that whatever that encompasses the environment. And let this not be the last session. Let it be the beginning of something better and new, where we get to meet each other in a much better place. So I like to thank all the panelists for being here. A lot of information was there. The ideas were from technical, non-technical, infrastructure area, policies. So I'm confident that the researchers here would be like, oh no, this many things are there to be discussed in this one branch that people always say like go green. But this go green has a lot of subsets. So thank you for being here. And I also want to thank the team who made this happen. The team of ArcNet team, Anthony, Suraj, Ravina, Jawahar, Abhinandan, all of them are here. If you can, open your video, that would have been amazing. If you guys are there, Joshita and all. So the entire team was working for this to find the right panelist with the right background. Even like Indumathi ma'am, we had to like go to extremes and all. So, and this finally happened. So this was the team who made this happen. And once again, thank you all, and I like to thank all the viewers here. And we'll be sharing this video to the students later so that they can learn more about it. And the questions would also be shared to you. And one last thing, the case study competitions would be open till 19th. And the submissions we would be going through, and these panelists would be mentoring all of you. So make use of it, and thank you. So on this note, I like to, end this meeting, and cheers to a new beginning.
Thank you. Thanks a lot.
Thank you.
Okay,
Bye.
Thank you.
bye everyone. Thanks
Thank you.
for being here.